All right, so this unit we are taking a look at ions. Remember, if we think all the way back to our atomic theory, it had originally said that atoms of a particular element are 100% identical. Well, we know that to be not true because last unit we learned about isotopes, and this unit we are learning about ions. Remember, ions are a charged atom. So when you're looking at a periodic table, it's not going to list its particular charge, it's just going to list its atom. Okay, so an atom would be a neutral element, whereas an ion is a charged atom. It can either be positive or negative, depending upon if it's going to gain or lose its valence electrons. When we look at our different groups, group 1 has one valence electron. So because it has one valence electron, it is going to either gain 7 or lose 1. Hopefully, if I ask you to run a mile, would you run 1 mile or would you run 7 miles? Well, hopefully you know that losing 1 would be a lot easier. So this is where the tricky part comes in. If I lose negative charge, so I started out with, let's say, 11 protons and 11 electrons, we know that that would be neutral. But if I have 11 protons and now 10 electrons, I now have lost 1. Protons are greater than my electrons by 1, I become a plus 1. So on your periodic table, you can actually, above where you had listed 1 VE, add a plus 1. For group 2, same exact idea. 2 valence electrons. We can either gain 6 to have a full outer shell and be stable, or we can lose 2. Again, doing 2 of something a lot easier than doing 6 of something. So if I lose 2, I become a plus 2. Remember, we skipped the middle transition metals, and then we go all the way over to group 13. Group 13 having 3 valence electrons. It can either lose 3 or gain 5 in order to become stable. Again, losing 3 a lot easier, so we become a plus 3 charge for everybody in group 13. Group 14, same deal, has 4 valence electrons. This is where it becomes a little bit trickier. Would you lose 4 or gain 4? Hopefully you know, well, that's kind of the same, I don't know. Our group 14 actually is not going to participate in ionic bonding, so we don't have to worry about a charge for group 14. Group 15, though, is where we take a look at our atoms that are nonmetals that are going to start to gain electrons. All right, so looking at group 15, we have 5 valence electrons. We can either lose all 5 and become stable, or we can gain 3. Well, again, we're going to go with the lowest number because that's going to be easier. So gaining 3 would be easier. So now I have more electrons than I do protons. So I have now a 3 minus, or a negative 3 charge. Group 16, we have 6 valence electrons. Lose 6 or gain 2. Hopefully you say gain 2. So that becomes a 2 minus. Group 17, we have 7 valence electrons. Lose 7 or gain 1. Hopefully you know gaining 1 a little bit easier, so 1 minus. And then up here, group 18, you got to remember those are noble gases. Noble gases are already stable, so they're not going to form ions, so they will always be neutral atoms. The charge is always going to be 0. All right, if you take a look on your periodic table, remember to the left of our staircase, we have our metals. To the right of the staircase, we have our nonmetals. Nonmetals will always tend to gain electrons because remember, we are trying to reach stability. We're trying to get an electron configuration that is similar to a noble gas. So if I'm going to gain electrons, I'm becoming more negative. So because it is negatively charged, I now can reach that stability. They can have that electron configuration similar to a noble gas. So for nonmetals, because they're gaining electrons, they become negative. Okay, if you gain electrons and you are negative, that is what we call an anion. Negatively charged atoms are called anions. Whereas if we look at metals, metals tend to lose electrons because, again, they're trying to become, like our noble gases, they're trying to become stable. So if you lose negative charge, you become positive. Positive charged ions are called cations. All right, so you might be wondering, well, where do these electrons go? Well, if sodium is going to lose an electron and chlorine wants to gain an electron, well, hey, that works out. Sodium is going to transfer one electron over to chlorine, and then both atoms now are stable. Both are going to be happy. If you look, a bond between sodium and chlorine, if I bond those two together, sodium is a +1, chlorine's a -1, add them together, you're going to look, I now get a neutral ionic compound. So again, if a metal loses, then you need to have something that is going to gain. So my metals are going to lose, and they're going to bond with a nonmetal that's going to gain. So I'm going to have metals bond with a nonmetal. Or an element from the left side of the periodic table bonds with an element from the right side of the periodic table. I'm going to have a positive charged ion bond with a negatively charged ion. I'm going to have my cation, which is a positive, bond with my anion, which is a negative. So no matter what, we are going to have one that is going to lose electrons, and we're going to transfer it to the one that is going to gain. So if you look, this is our yin and our yang, right? So in nature, we can't have any matter created nor destroyed. So if those electrons are going to be lost, they have to be lost and transferred to somebody else. If they're going to become stable, they need to have that partner. So that's kind of where that yin and yang comes into play. So again, those valence electrons are going to be the determining factor when it comes to our chemical properties. They're either going to be gained or lost. Remember, if you're gaining electrons are negatively charged, you are negative. If you lose electrons, you're losing negative charge, you're going to become positive. Please be extremely careful. In math class, you think gain would mean positive, and you would think lose means minus. You got to be careful. It's actually the opposite, because we are gaining and losing negatively charged particles. So again, we walked through this. We had group 1 tends to form a +1 ion, group 2 is a +2, and group 13 is a +3. So for the most part, we will ignore group 14 because they can either gain or lose for electrons. So for most of our elements in group 14, they actually will not participate in ionic bonding because they don't form ions. So like carbon and silicon will not. But there are some rare exceptions with germanium, tin as well, where they could possibly form these ionic bonds. But for the most part, we will ignore group 14. All right, so our nonmetals, group 15, 16, and 17. If I look at nitrogen, nitrogen has an atomic number of 7. So when it is neutral, the electron configuration is 2, 5. So if I consider just my valence electrons, I have 5. I can either lose those 5 or I can gain 3 in order to achieve an electron configuration of a noble gas. I'm going to pick gain 3 because that's a little bit easier to do 3 of something than it is to do 5 of something. So nitrogen and all the elements in group 15 tend to form a -3 charge. Because it's negative, remember, negatives are called anions. And then if I follow the pattern, group 16 becomes -2 because it has 6 valence electrons. 17 becomes -1 because it has 7 valence electrons. So you might start to notice that if we become like a noble gas, our electron configuration is either going to be a 2, a 2,8, or a 2,8,8. So we're going to end up with either a total of 2 electrons, 10 electrons, or 18 electrons. Okay? So each and every single time, again, our goal is to become like a noble gas, to be stable. Okay? And because these ones are gaining electrons, they're gaining them from a metal who is losing the same number of electrons. All right, when we look at that Bohr model, again, we just have to look to that outermost shell. The outermost shell is going to hint us in on how many valence electrons you have, and then we want to try to fill up those valence electrons. So if you look, carbon, 1, 2, 3, 4, we could add 4, which would give it a negative charge, -4, or we could actually lose 1, 2, 3, 4, and become a +4 charge. So remember, group 14, a little bit harder. We tend to ignore it because not all are going to participate in ionic bonding. All right, so when we do a Lewis dot diagram, you want to make sure when you are doing the dots, you're doing it one particular way. So for example, oxygen, my Lewis dots are just our valence electrons. So because it's in group 16, I know it has 6 valence electrons. So when I draw this, I'm going to put 1 dot around, and then I'll add my second dot. Now, I really want you guys to follow that same pattern, because if you look, do you see how there are 2 spaces that are missing their partners? So if you notice, that means that it will form 2 bonds then, because ideally it would like to gain those 2 electrons. If I draw this like this, 1, 2, 3, 4, 5, 6, it's a lot harder for me to try to identify how many electrons or how many bonds it's going to form. I also don't want to go around just like that. So please make sure you are following the same procedure where you add 1 electron to each spot around the element symbol and then add the second one. Okay? If I am looking at something like fluorine, fluorine has 7 valence electrons. I go 1, 2, 3, 4, 5, 6, 7. So look, there's only 1 spot that's missing. So I'm guessing I'm probably going to gain 1 electron from a metal. All right, so again, you want to make sure that you're including those Lewis dots. I'm sorry, some of mine kind of get shifted over here. But again, those Lewis dot diagrams are just based upon the valence electrons. So here's a good example of all the ones. And again, I'm sorry, some of the dots got shifted. But we are just going around, like for example here, argon, it got shifted. 1, 2, 3, 4, 5, 6, 7, and 8. Chlorine, same deal. 1, 2, 3, 4, 5, 6, 7. Sulfur, 1, 2, 3, 4, 5, 6. So anytime it's missing its buddy, sulfur missing 2 buddies, it's going to form 2 bonds. Chlorine missing 1 buddy, it's going to form 1 bond. Hey, look. Argon's not missing any buddies, so that's not going to form any bonds, because if you remember, these are noble gases. All right, so again, here's another visual of our Lewis dot diagrams. Take a look at sodium. Sodium just has the 1 outside. Fluorine missing its 1 buddy, so I'm guessing that sodium might transfer that electron to fluorine, and then they'll form a bond. Hey, so that's kind of where we're going in the next few days. So we're not quite there yet, but that is just a hint moving forward. So here's just a little fun comic for you, just saying that, you know, negatives are attracted to positives, metals attracted to non-metals, positives attracted to the negatives, because opposites do attract.